This one here, I was very pleased to figure out. It all started from a tweet. This is server-side template injection. Now what happened here was there were people posting on Twitter, I just found a new SSTI shell. And they had this code line that went on for like 3 or 4 times across the tweet. 3 or 4 lines, hundreds of characters, like a really long SQL injection. And I said, I don't even know what that stuff is. And I wanted to find out, so I learned. And you can make your own server, but I've got a server you can use here, and that's what I'm going to use. So if you go to this server, this is somebody's demonstration of this vulnerability, server-side template injection. And it goes like this. You can search for a user like Joe. And when you do, it will say user Joe exists. Now there is no actual database, and it always tells you the user exists. The interesting thing is, how does it process the input from the user? Now if I put in 1 + 1 and search for it, it treats it as text, which is what it should do. However, this is a modern web page. And modern web pages are not just written straight in HTML anymore. They are written in languages that include meta tags that fill in from databases so they can dynamically change the contents of the page. So they can do something like read your cookies like Amazon does and show you different specials and stuff because it knows who you are. And those things go in special characters to be the meta tag. So the first thing you have to do is fingerprint it. So if you put in this stuff with 2 curly braces and then some mathematics inside, let me rip this tab off so I can have it visible at the same time as my instructions. All right, let's get rid of Wireshark. All right, there. Make this bigger. All right, so if I put in that stuff in curly braces, 2 × 2, now it tells me user 4 exists. So now I have got a code injection vulnerability. I can inject in what's supposed to be a name, I can inject code and it will do the calculation. But it's not in a normal language, it's in whatever this SSTI language is. And you can fingerprint it this way by trying things like this 7 × 7 with single curly braces and a $sign. This is how I fingerprint the template engine being used. There are several popular template engines. If this one is evaluated, then you go the green line, but I'm going the red line because it was not evaluated. That one just sat there without being evaluated. So I'm not using Mako. This one here is evaluated, so I go to this one. Anyway, so you can find it out. It turned out that we're using Jinja 2 if you fingerprint it. Anyway, Jinja 2 is a Python-based templating engine, and now you can get away with murder. You say, what can you do when you can just inject little code like that? The answer is you can totally take over the box. You can make a reverse shell from it because it's running on Python 3. And here's why. This is what I wanted to show you. So let's bring in a command line that's got Python 3 available. Okay, and make sure it's fitting in my window. That looks pretty good. Okay, so I run Python 3. And so what's happening here is I control a string like this one. Let's do all these and then talk about them. All right, so I make a string like hello. Okay, we've been using this all along. I remember I mentioned long before that everything in Python is an object. It's an object-oriented language with inheritance, which turns out to be extremely dangerous. If you use the directory function, you can find the attributes and methods of an object. Just a string has all these crazy attributes and methods. And you may remember we did string find here. We used that before. You can run a find method on the string. You can do all these other things too. So, for example, you can use __class__, and it will tell you what type of object this is. This is class string. You can do s lower, and that will show you the built-in method. if you don't put the open and closing parentheses in, it won't run it. It will just tell you what it is, like a help message. If you do put in the upper and lower opening and closing parentheses, then it will evaluate it and change the capital hello to a lowercase hello. But what's interesting to us here is walking up the hierarchy. So if I take S-class, that's a class string. Well, I can wonder, what's the class of that? That's class type. And there's something called base that tells you what's higher in the hierarchy than where you are, and that's class object. So that's what this diagram here shows you. You can take an object that appears to be harmless, like a string, and you can add these modifiers to it to walk up the hierarchy. So I can do S-class class and get to type, or I can do S-class base and get to object. Object is the root of the entire Python 3 tree. So I can walk back down from that with subclasses, and I can find out what objects are available to, what attributes and methods are available to an object at the root of the tree. And it will turn out that there are hundreds of methods, and there is one of those methods called catch warnings that is used for something like generating error messages, and it has an import method. So I can take code running on a server designed by a developer to handle processing strings, and by adding just this kind of stuff to the end of my string, I can find an import function, and I can import a Python library into that code that the developer did not import. So I can import OS system, which gives me the ability to execute bash command lines. If I do that here, import os.system, let's try import OS. Okay, then I can do os.system of date. There, this is what I want to show you. If I can import the OS library, I can execute system calls. I own the box. I can now execute system calls in the underlying operating system, which is Mac OS in this case, and I can then open a shell, do anything I want, find privilege escalation vulnerabilities, and so on. So this is what's mind-boggling. Just by being able to inject a string, which is then processed by Python 3, you can import a new library and gain code execution on the box. And you can do it right through this Jinja 2 stuff. So there's a lot of steps here. You get these long things, but you can totally gain arbitrary remote code execution. Here, I'm able to do this, and then you can take over the box right through this thing with this sort of thing. So see, if I do hello class, I see type string, and on the whole game, you can eventually take over the whole box that way. It's entertaining and mind-boggling, and it lets you understand a lot more about how Python internals actually work. Anyway, that's what I wanted to show you.